David owns a company, and it's known that his weekly cost of producing X items is given by this expression here, between 0 and 10,000 items. The revenue is given by this, and that's for each item. That's going to become important later in the question. So determine the average cost of the first 1,500 items produced. So if we work out the cost of 1,500 items, so that's going to be 75, not 72, 75,000 plus 100 multiplied by 1,500, take away 0.03 multiplied by 1,500 squared, and then we've got plus, I need to make sure I get the right number of zeros here, 1, 2, 3, 4, 5, so 0.1, 2, 3, 4, 5, 4 multiplied by 1,500, and that's cubed. So that gives me 171,000. So it's an average cost, so what we need to do is divide by the number of items. So it's going to be 171,000 divided by 1,500. And that gives me $114. Determine C-100 and explain its meaning. So we need to differentiate. So this disappears, then we get 100. Take away 0.06 x plus 0.1234, so at the moment that's 1, 2, 3, 4, 5, and the 4 multiplied by 3 will be 12, so that will be 12 x squared. Don't forget you've got the calculator to help you with all of this stuff. You can differentiate this on the calculator. And C-100 then, so we just need to substitute 100 into this. So that's 100. Take away 0.06 multiplied by 100. Add 0.00012 multiplied by 100 squared. So that's 94.12. So an estimate of the cost of the 101st item, it's always the next item, 101st item is $94.12. Should just note that somehow, compared to the written solutions, these two parts are mixed up, but it doesn't really matter. Determine the weekly profit. Well, we know that profit is revenue take away cost. Now the revenue, this is for each item, so what we need to do is just multiply that by X. And then we're taking away the cost, which is the 75,000. Let's make sure we put this in a bracket so we get all the signs right. That's 100x. Take 0.03x squared plus 0.00004 x cubed And then all we need to do is simplify that, and it simplifies down to negative 75,000 plus 100x plus 0.025x squared, take away 0.00004 x cubed. How many items would David expect to sell each week before he makes a profit? Note that this is only one mark. There's all sorts of ways we could do it. We could solve the profit expression on the calculator. I'm going to do it by graphing, I think. So, graph and table. Let's just clear anything we've got at the moment. And what we've got, negative 75,000 plus 100x plus 0.025x squared, take away 0.00004 x cubed. A graph, and we're not seeing anything at the moment. That's because of the window. So let's go x is 0 to, well, this says up to 10,000, so why not put that in? And we know that the costs could be quite big, so the profit's likely to be quite big as well. So let's make that up to 1 million or something. See if we get a better picture. There we go. And we were interested in where it actually cuts the x-axis, so maybe it might have been better to make that negative 1,000 or something like that. And then we know that he makes a profit once it's passed here. So analysis, gsolve, root, and here we go. So we can see that that is 654.2. So we need to go up to the next item. So it's going to be 655 items. 654.2 indicates that at 654 it's still below, so it's still a loss, but 655 would be above. Determine the maximum profit that David could expect to make per week and the number of items that he should produce each week to ensure this maximum profit. Well, we already had the function in the calculator, so maximum will be up here. Analysis, gsolve, max. So we've got 5643.33. So I think we need to check at 5643. So that will be profit there, and 5644 to see which one is actually best. So we can do that on here. So analysis, gsolve. If we do a ycal when x is 5643, that gives us 5666, 5666, 15, and that looks like 89. And then do same sort of thing, another ycal. We'll do this one at 5644, and that is 566615 88. So it's just 1 cent less. So 5643 items, and the profit would be 56661589